Hi guys, here I am again with an example on how Claude Code makes working inside Isaac Sim a lot easier. In this video, I outfitted a manipulator with collision and physics properties, as well as inverse kinematics that works well enough to follow an end-effector target. If you're looking for step-by-step instructions on how to set up Claude Code with Isaac Sim, go to my Intro to Isaac Sim with Claude Code video. I'm using one of Agilex's Piper arm as an example here if you want to try out exactly what I did. But this isn't meant to be a tutorial, but more a demonstration of what you can do with a coding agent in the loop with Isaac Sim. If you followed my previous setup video, you should already have 3 Python files inside your project directory. These files are the communication protocols Claude has with Isaac Sim, both for sending commands and for retrieving data. You should also have a Claude.md that's populated with information that Claude himself has gathered about Isaac Sim and your project. To start, let's put a robot on stage. I downloaded the Piper Isaac Sim repository from Agilex's Robotics GitHub. This one already has a bunch of USD format of the robot, so I'm going to use that. It also has URDF files and meshes and whatnot in the same repo. Isaac Sim has a pretty robust URDF converter, so you can also start with that, but I just happen to use the USD version for this recording. I first opened up the USD file itself. There's a robot in here, and if you look at the stage tree, there's some other stuff in here as well, like a ground plane and an action graph that looks like publishes camera images out via ROS nodes. You can keep them if you want. I'm actually going to move all of these out of the default prim so that there's only the robot itself inside the default prim. This way, if I ever load this USD as a reference, which you probably should if you are building a complex environment, you only get the robot and nothing else. Okay, I'll save this version as a separate USD file. Then I'll start a new stage and drag this USD file onto the scene, which load it as a reference. And as you can see, now it's just the robot that's showing up. I'll still add some kind of ground plane, but I like this one better. And I'll move the robot to the origin. So my collision mesh visualization is already on. That's why you can see that the ground has purple rings and the camera has a green box around it. But what that's telling me is that there's no collision mesh on the robot itself. So the first thing I'm going to ask Claude to do is to give the robot collision and physics properties. Oh, by the way, if you want to see the collision meshes, you open up the eye icon on top of the viewport, go to Show by Type, Physics, Collision Colliders, and then select All. Okay, it's added some collision meshes to the robot. As you can see, the green outlines that's surrounding the robot body itself. It shows a pretty loose fit of the meshes, so it's not following the exact contour of the robot, but I'm okay with that for now. The more obvious issue here is this offshoot from the gripper. I don't know where that's coming from or what's that about, but the collision mesh for the gripper is a pretty important one, especially if you want the gripper to actually do something like picking up objects. So I'm just going to describe what I see and ask Claude to fix it. Okay, it's figured out that there are stray vertices, and it looks like it went straight into the USD file and pulled out the data on the vertices and did a statistical analysis on it and found that they're outliers. And the reason about it and decided it was safe to just delete it. And it did. It actually looks like there's still one more that's slightly closer, so we'll just ask it to do it again. So here you can see that Claude is claiming that everything's fixed, but it clearly isn't. This is kind of typical behavior that I've been seeing, where he would claim something is done when it's not entirely true, especially if it's only checking things visually. So it's probably wise to ask it to confirm actions in some other ways or set up multiple camera angles for visual confirmation. But for sake of this demonstration, we're just going to leave it. And so you can get an idea of how the back and forth between the user and Claude look like in order to make progress. Okay, it's deleted the other extra vertex, and now the collision mesh looks nice and tight around the gripper fingers. Perfect. Let's just do a quick check. If I move the joints around so the robot hits the ground, it should collide as opposed to going right through it. Cool, it's doing that, great. The next thing I want to do is that instead of joint control, which is what I was just doing, move these joints around, I'd rather do end-effector control. There's a follow target example inside Isaac Sims example vault. I basically want to do that, so I'll just ask exactly for that. The follow target example may seem pretty straightforward, but there are actually a few things behind the scene that it's doing makes it not a straightforward copy and paste, namely the inverse kinematics piece for the robot. In the example, the robot is using something called an RMPflow, which if you set it up correctly, it can do this cool IK with obstacle avoidance. But that's a big if. There are configuration files with lots of knobs you have to turn, and unless you know the math behind it, they're not the most intuitive numbers to tune. So I think lots of times people just give up on the RMPflow and use the more generic IK. But let's see if Claude can figure it out. It looks like it is indeed digging into the RMP library and finding the config files and parameters that are relevant. And it wrote some configuration files of its own. Okay, it's now saying that the robot is moving towards the target just very, very slowly. I'm going to guess that it has to do with the joint stiffness being too low. Let's find all the joints and look at the stiffness and damping parameter. Yeah, these numbers look a bit low. So I'm going to pause Claude and tell it to turn up these joint stiffness and max forces, and then let it continue to figure things out. Okay, I think it's figured it out. I'm moving this target around and it's following it in an acceptable speed. So that's incredibly impressive to me, to have it figure out the RMPflow library, update the configs, and give us a working robot. I can't actually say it's using the RMP absolutely correctly, but it's sometimes just a lot easier to edit than writing something from scratch. And by having a working robot in front of you, you can now start performing tests, or instruct Claude to write and perform tests that you need to make sure that the robot is behaving as expected. You can also have Claude explain things to you if you need to dig further into any particular library. But that's just to show that Claude can be incredibly good at getting you to a place where you can make meaningful progress and teach you a lot of things on the way.